We're going to look at Backus-Naur form and parse trees. Now, parse trees, what they allow us to do is to check whether a string is valid for a given context-free language. This is used, for example, to check whether the syntax is correct within our program code. So when we're writing code, what happens is during the interpreting or compilation stage, what happens is that there will be some checking of whether the syntax, whether the code that you've written is correct. So with a parse tree, the way it works is we start with the top production rules and we try to identify the terminal symbols, the terminating symbols, and we progress down the tree until we've identified all the terminal symbols, all the terminating symbols. Now we need to make sure that all our symbols have been accounted for within our parse tree. Otherwise, we're going to be in a situation where we don't have a valid string. We're going to do a work-through example of a parse tree for the production rules that are presented here for representing a number. So numbers can be integers, numbers can be real numbers, they can be prepended with a plus or a minus or have nothing at all in front of them. So this is what this set of production rules allow us to have. We've got some example expressions here on the right hand side that these are all valid. So you can have plus 23.71, you can have 8.4, or you can have minus 345. So we can have a range of numbers. What we're going to do is check to see whether minus 27.01 is a valid expression given these production rules we have here. So these could be production rules for representing number, perhaps in a programming language. Let's begin with our top production rule, signed. And you can see that can either be number or plus number or minus number, while the number we're trying to test to see whether it's valid is minus 27.01. So we're going to take the minus number option here. And what we'll find is that we've now found our first terminal symbol here. So that's the minus. Remember, we need to find all our terminal symbols within our expression minus 27.01. We found the first one, which is the minus. So then we go to the number production rule. That can be a real or an integer. Well, we're following the real path here because we've got an integer before a point and after the point. And if you then go to that next production rule, which has a point in here, and our two integers either side of that decimal point. So our decimal point now is an identified terminal symbol. So we've identified two terminal symbols by this point. Our integer, both our integers are made up of digits, of course. So we're going to now go to our integer production rule here, which is made up of a digit and an integer in a recursive fashion. So we found our first digit in each case there, which is the 2 and the 0. So those are our terminal symbols. And to find the second digit here, we have found that in both cases, which is now the 7 and the 1. So we have identified and found all our terminal symbols. So we can say now that this is a valid expression given these production rules that we have. Just for good measure, we're going to work through another example of a parse tree, this time for representing an if statement. You can imagine this within a programming language to check to see whether the syntax you've written for an if statement is correct or not. So what we're going to do is check to see whether our if statement here, so if open bracket A is greater than 1 close bracket or open bracket C does not equal to close bracket. So if that statement at the top there is valid or not, whether that would return a syntax error or not within our programming language, given the production rules that we have given here. So let's start breaking this down. We'll start looking at the parse tree for this. So let's begin with selection. We need to use the right-hand most option here with the logical operator here, because we have the or in our statement. And within that, then we can identify some terminating symbols already. So we've got the if open bracket, the close bracket, and the open bracket and close bracket of our second expression. So we can identify those both pretty much straight away there. You can see that there. So we've identified the brackets and the if. Next thing we can do is because we have the logical expression here as well, so that is either an and or an or terminating symbol, so we can also identify the or as well at this stage. Next we take our expression, and that's made up of variable, operator and number. We have two of those expressions that we need to pull apart a little bit here. So our variable and our operator on a number, well, our variable can be made up of a letter, you can see that here, and our operator and additionally our number here, well, these are made up of terminating symbols. So operator here is greater than, and the 1 and the not equal operator and the 2 there, so we've identified those. Then we have our letter here, and we've got A and C. In this case, we've identified both of those, and you can see now that we have identified all of the terminating symbols within our expression, and so we can say that this is a valid expression, given that we've been through the parse tree, and our expression for our if statement at the top there is perfectly valid given these production rules that we have here.